Medical imaging today is based on inventions that are several decades old.
The dilemma is that we have got nowadays modern three-dimensional radiological data, and we don't use all the benefits we could.
Our DPI project is creating a new method for digital imaging.
This method can be thought as diving into imaging data.
We are building a digital patient.
Virtual reality and multimodal interaction techniques make the work efficient and natural for doctors.
We can make a diagnosis out of the patient, operate planning, and teach students to do this digitally.
We want to create novel, natural feeling tools to help medical work.
Tauki Research Center studies novel interaction methods such as speech, eye tracking, gestures, and haptics.
In real three-dimensional world, you can have all these together, and that would be our dream.
My next guests are Jorma Järnstedt, Specialist of Radiology at the Tampere University Hospital. Roope Raisamo is Professor and Head of Research Center at the Tampere University Tampere Unit for Computer-Human Interaction. And Arne Slenska, who is a doctor but now also a businessman. He is CEO for a company called Osgenic. Now, this video we saw was really, really cool. It was like looking at a science fiction movie, partly. Jorma, where did this idea for this project come from?
Well, actually, it's based on the fact that during last decade, the number of 3D imaging has increased extremely, but the number of doctors has not increased. So the workload is very heavy. And in the future, nowadays, we don't use data only for diagnosis, we use it also for computer-aided operation planning. So there is a need for new time and to get out of the box. We talked in our department with my younger colleagues that we need a better way than just two-dimensional flat screen and a mouse as our tool. We want to have a patient in real 3D, like the fantastic data is what we got nowadays. To do in the 3D or mixed world, same time, diagnosis, reporting, and operation planning using new tools, perhaps feeling, having haptics, feeling of the patient, and together with our colleagues or surgeons, and even teach this to new students starting from when they start learning basic anatomy. That was the idea.
So you thought of this, but did you know, was it possible? Like, is that when you called Roope?
Well, first I talked with my youngest colleague. One of my residents, and I know I'm an older man. I don't know everything what has been made, especially in the gaming world. So then we got the opportunity to call Roope.
Okay, so what is your solution to the problem of understanding this imaging data?
I could say that it was great to meet Jorma and Helena when they had this problem, and we right away saw that we have a solution. We can use virtual reality, but as you saw in the video, the glasses, you can see virtual reality in 3D, and you are able to dive into medical data like human body, zoom in, you can feel it, you can know where you are watching at, and the computer can bring more information about that. So we thought that we can provide what they need, and together with many companies, we have been able to start this work.
But how can this, the interaction, use as building a digital patient and watching it with, how can you make it feel like natural and efficient?
Well, we designed the interaction so that it's multimodal, making use of all human senses and ways of acting, and it is as natural for humans as possible. So it's like you are discussing with another human and controlling this environment.
So you have the glasses, and yes, the woman in the video had the glove?
Yes, and we have a microphone for speech. And we have special devices for providing a touch feedback, so you can feel it really.
That's really cool. Okay, Arne, you're a former surgeon, but now you run the company Osgenic. So what does Osgenic do? And also, how are you hoping to benefit from this collaboration?
Yeah, so at Osgenic, we have created an online surgical training platform that leverages VR for better 3D perception of anatomy and some assessment of the user. And what we aim to do with this is get better competency-based and structural training for resident surgeons. Now in this project, we are working a lot with 3D anatomy and as also we at Osgenic. And what we want is better and more intuitive ways for using this data. Because everybody who has tried VR knows that kind of these controllers and everything aren't always the most intuitive way to use that. And if you want to bring a tool to a hospital or to surgeons, it needs to be easy to use and easy to understand. And that's what we are especially aiming to get from this project.
So we were talking about using this in teaching new students how to work, but what other concrete applications are there here to be used? You said about planning operations?
Yes, operation planning is very important nowadays. We can save time in the operation theaters and recovery of the patient is much faster, and especially when we are operating very complicated operations, it can be guided or made on computer before, and that's very important for. And of course, in the future, there must be AI also involved. It can in AI and can give us important anatomical landmarks, as we discussed before, and it can also simulate the operation where to put the cutting, and so and somebody could also practice on the same patient.
Oh.
He is going to, or he or she is going to operate next day.
Would it actually feel like?
Yeah, that's.
It would feel like you're cutting open.
Yes,
like
you
a
can really
brain.
feel it like normally.
Wow. Okay, well, that seems like that's a good thing because I would love for people to practice on fake brains before they practice on my brain. Okay, what needs to be fixed in the present radiological work process that you hope to get work
The
here?
present process is very efficient, but it's time consuming, and it's just sitting and playing with the mouse. It's economically, and it's because of I mentioned before that larger amount of studies coming every day. Every day it's getting more stressful and stressful and stressful. That's why we have to get new tools, because we cannot make more in less time anymore.
And you said artificial intelligence can help, but how exactly can artificial intelligence help in these processes?
Well, I might say that it can close out some simple things that take plenty of time, but they are simple to detect. And the doctors can focus on the most interesting and most difficult parts of the diagnosis. That is one of the main uses.
Okay. How quickly do you think that some of these products can get to market?
Well, this is still a research project, so Roope can tell more about the research part, but as we know, this is a regulatory tool because it's used for diagnosis and using patient-specific data, so that always takes time. So even after the research project is done, it will take years to be like available like on a broader scale. Of course, piloting in smaller environments is what we do then first, and it's always important to understand that everything needs to be really validated and not only having a CE mark or something on it or a medical device regulation mark on it, but also peer-reviewed scientific papers that are in magazines that validate that it really creates benefits.
I could continue that in addition to Osgenic, we have other company partners, and it's possible that already within 6 to 12 months, some of the features we have been studying will be part of their products. But if we think about the complete DPI system, it cannot actually be commercialized during the research project because of the rules even. But soon after that, we can have another continuation where we go closer to market, and then together we can bring a new solution to the market. But it takes years in any
Okay.
case.
Roope, what still needs more research?
Well, my field is human technology interaction, and that means that we have to understand human and technology together. So we are studying ways to present information to the human using different senses, like vision, hearing, feeling with touch, and then also combining these and making it as natural as possible. So it requires experimental research in the laboratory, but then also development of the technology is not complete. Like if we want to have full hand haptic interaction, like with all of your fingers, we don't have this kind of device available in the market, but we can make it happen. But that's like creating really new technology and then testing it in the real cases.
So would you say that this is medical research or is this like technological research?
It's a combination.
It's a combination, definitely.
Yes.
Okay. What benefits does a company have from collaborating in this type of research project?
Well, first of all, like companies, startups normally have limited resources, and of course, like limited knowledge, often of the medical field. So combining this, that you get to collaborate with the university on the technological side. So from Roope's side, and then like with the medical experts from a university hospital from Jorma's side, it's of course invaluable for many companies to have these resources. So you get much broader on that and normally we cannot have this, and of course getting the funding also for us from Business Finland for these kind of projects, that's quite unique, I think.
Have you tried some of these things in your job, in your work already?
Not in the job.
No, but like, have you kind of practiced?
Oh, of course, our practices, it's wonderful.
And it feels real? It's like really good?
Yeah, but still needs a lot of work, but still it's in the way I imagined a couple of years ago.
Cool. We have a question from the audience. So they're saying, what an exciting project. Thank you so much for sharing your work. Outside your own projects, where do you see the greatest potential for use of virtual reality in healthcare?
Well, there are really many possibilities. One common use is training and education, like what Osgenic is doing. But then it can actually be used in any case. We are starting from facial area in this project, but of course we can move to other parts of the body and use the similar techniques also there. And that is one of our plans for the future, to go from the facial area to other parts, where actually we get the best benefit from this technology. Like very hard things to diagnose should be allowed with the new technology to make it easier for the doctors.
I agree. So you were saying this was a joint, this is not only medical research, not only technological research, it's a collaboration. How did you guys start in the beginning? Was it easy to find a common language? Were you noticing that you weren't communicating right, or?
Do you want to start?
I think there were no difficulties at all at the beginning.
At the beginning.
Yes. Now, when we are getting deeper and deeper, you have fancy names for details, and I said, what are these? But they are willing to explain it to me. But actually, no.
No. So in the session before, they were saying we have to teach everyone to think more like a data scientist. Now, I think Roope already thinks like, no?
We don't have this kind of problem here, I think, because when we do research, it's a user need-based, and we have the need here. So we heard the need, and we will develop together the solution, and then we study it in scientific experiments. So it's like our normal way of business. We have the need, we have the solution, we study it.
Okay.
So it was clear, because they had clear need. Often you don't know the need, or the people who need something don't really know what is available, what can be done. But they also knew that. So they said that maybe we want to use virtual reality, and then we started discussing.
Yeah, and I'd say we need to teach everyone to think more like a doctor. So understanding what are the problems of new technology in healthcare, like integration into workflows, where can we integrate them and make them really usable and make them intuitive to use? What does the user want from this tool? What applications does he have? What features are the most important? I've seen a lot of technology in healthcare during my clinical career, and I think one of the biggest lack is the lack of intuitive user interface, because the doctors haven't been involved in designing the user interface from the first steps of this product.
And now they are.
And now they are. So
Yes.
the products used to look engineering, but now they look like actually useful for medical professionals.
Yeah, I also.
User-centered
Yes.
work. I would also say that very important is the working process in the hospital, and that's part of the project that our team in Taus Hospital, they will integrate these new solutions in their practices, but that also takes some time to make it really happen.
Yes.
Thank you so much.